Hi, my name is Ben, I'm with Phoenix LiDAR, and today I'd like to show you our hybrid SLAM workflow. As an example, we're going to map this church using both an aerial as well as a SLAM survey, and then merge those data sets. All of our multi-laser units can run SLAM, but for today we're going to show this using the RECON-XT. Before we capture any other data, I'm going to set up my reference station. I'll explain more about this later. So, I've already set up our reference station, collecting some raw observations, and already mounted the RECON-XT to the M300. So now we can go and fly. For the aerial scan, we're using page 2 of our quick start guide. Meet our pilot in command, Alex. He's gonna fly the M300 now. We're done with the aerial survey, so I'm going to take the RECON-XT off of the M300 and mount it to the SLAM handle. The SLAM handle mounts to the Recon, and the antenna mounts to the camera on the top. I also have a battery pack on my belt, powering the Recon for the duration of the SLAM. The reason we call this hybrid SLAM is that we don't just SLAM, but we can reuse the same reference station that we used for the aerial scan to get a precise RTK fix to this antenna, before, during, or after the slamming. So these make the SLAM as accurate and as geo-referenced as RTK GNSS can be. And that means that in post-processing, you don't need to spend much time to align your SLAM cloud to any other existing data that you may have. Slamming is actually pretty easy. All you gotta do is move the scanner calmly and be sure to paint all the surfaces you want in your point cloud. This room is great because it's large and most walls are clearly visible from the center. So this just takes a quick visit. Depending on if you're just looking for a rough floor plan or you want to capture the whole room in detail, you would spend less or more time in the room. So I just want a floor plan, so that didn't take me very long. And here's another opportunity to capture an aerial control point. So I'll hold the scanner up and wait a couple seconds for a GPS fix. And I'll go back inside.
SLAM processing isn't hard either. All we do is copy the data from the unit and open it in Spatial Explorer. First, we compute the GNSS solution from reference station to rover. For SLAM, we really don't need a full trajectory with orientations. We just process differential GNSS to get accurate positions of when we were outside. Now we start the actual SLAM processing. We can immediately see the unit itself, the trajectory, and the point cloud. Because everything is time-stamped, we can snap the SLAM trajectory to the GNSS measurements. Together with SLAM doing loop closures, that improves the cloud's relative accuracy, meaning that the cloud is consistent with itself. But it also provides absolute accuracy, meaning that the data is well georeferenced. Because you can actually see SLAM process and not just the finished result, you can learn how to improve your efficiency and accuracy. Also, you can start and stop processing at any time or merge with another SLAM run for better coverage. That's why I think you want to process most SLAM datasets interactively. Now, marketing aside, the truth is that SLAM isn't always perfect. So we added a way to manually align the cloud to a GCP or to itself. In this case, we're comparing GCP 7 to parts of the cloud that were scanned from far away. We colorize the cloud by time and just slightly lift the yellow part to match the GCP. After clicking Optimize, we can immediately see the improvements. And once that's done, this is just another point cloud that can be processed like any other aerial or mobile cloud.
Thanks for watching. I hope you learned a little bit about hybrid SLAM and how it works. And if you're interested, there's a link to the data in the description, so you can go in yourself and see how well the SLAM cloud and the aerial cloud match up.